going on.
Dark matter, right.
So,
All right. So, if you understood the concepts here in the conversation before this question, it's only really one step, maybe two.
You got it wrong. You got it wrong. Hi, Dylan. Just literally yeah, do the left fraction. You put R over mole over, and then it ends up being 100. So you did what I did wrong. I did the wrong thing. Yeah, I did.
That's what you did.
Yes, that makes 18 over.
Do they?
All right, the answer is whatever Kira says.
0.17648.
Good, 0.176 ATM, good job. Here's how we do it. Pressure of O2 is equal to, what is it? 18.0, and that's 100, isn't it?
Yeah. Yes.
Okay, 100 is the mole fraction, or 100 is the total number of moles. So that's 0.18 times total pressure, 0.980. So 0.18. So Marcy, in the equation, you can leave it like that if you want.
Okay.
But if there's ever a question asking what is the mole fraction,
I wanted
put a decimal.
Decimal, because I thought since it was called a fraction.
Yeah, okay. So, yeah, just think decimal. All right, so what was it again? 0.16? No. 176. There it is. Good job. That's it. That's it. So, just real quick to prove what we talked about earlier, the total, so we could do xt, which kind of is a silly way to write it, but it would be 0.18 plus 0.805 plus 0.015. So if you add up all the mole fractions, this would be the mole fraction of O2, mole fraction of argon, mole fraction of, what's the other one? CO2. Those are all equal 1. So the mole fractions will always equal 1 because they're all a percentage of the total number of moles. So that's a pretty easy one to start us off with here. I don't know which one I want to do next.
I didn't get the ratings.
Oh, okay. What this part maybe? What did you try and do? PV equals nRT?
I have no clue what I still do.
Okay, well, this is the way I was hoping you would do it. Use the partial pressure equation.
Yeah, I use that.
Partial pressure. So the individual mole of oxygen is just 18. The total number of moles on the bottom. So you have to add these three numbers up. That's your total moles. That's where that number comes from. 100. When you divide that, you get 0.18 multiplied by the total pressure which was given, and that's the individual pressure.
Yep. I made this way more complicated.
Good. I'm glad you figured it out at least. All right, so real quick before I get to the next problem, let me just explain this again. It's really important to me that you understand the concept here. When you take the mole fraction of the oxygen, what are you really finding out there? Like, why is that necessary? You're finding out what? The number What was the question? Why do we have to figure out mole fraction? What does that really tell us about this sample of gases? It doesn't tell us the number of moles of oxygen, because we know that, it's 18.
Percentage of moles.
Right. So you have all this space in this container, right? So you have a container. They're all bouncing around, but really we're trying to figure out, maybe an easier way to figure it out, what percentage of this space oxygen is kind of taken up. That's essentially what this is telling us. How much space are the number of particles of oxygen taking up, and then how does that affect the total pressure? So that part, that percentage essentially, is multiplied by the total, and that gives you the individual amount of pressure just the O2 is bouncing around in here producing. So that's why that is necessary. You can't just take the moles, you need the percentage of it. So what part out of all of them is the oxygen kind of bouncing around? That's hopefully makes a little bit more sense. But that's why this equation makes sense and why we use it. All right, next question. And we're probably going to run out of time. Okay, mixture of gases with a total pressure of 2.1 atm. So we have 2.1 atm is the total pressure at 25 degrees Celsius. So we have a mixture of gases at 2.1 atm at 25 degrees Celsius. They're contained in a 250 liter vessel, a rigid vessel. The AP test might use the word rigid. What does that mean?
Non-flexible.
Good. It won't expand, right? So then, therefore, you can't argue. I can't answer this because it's expanding. It's rigid. 250 liter vessel. Mixture of gases made up of helium, oxygen, and nitrogen. A mixture of what did I say? Helium, oxygen, and nitrogen. If the pressure of helium is 0.75, pressure of helium is 0.75 atm, and the pressure, I should be writing, sorry, partial pressure, and the pressure, partial pressure of N2 is 0.55 atm. How many grams of oxygen are there in the mixture? Wow. How many grams of O2? Let's find out. That's right, Ben. Let's find out. The bell's going to ring, so copy that down, and then I guess that's probably it. Homework due Monday. I'll write it up now. So it'll be up there. If you want to wait, you can copy it down. Due Monday, chapter 5.
From there, you can find everything you need. Logic.
This is kind of a lot, so you might want to work on it before Sunday night.
Logically,
Well, I mean, it's only 5 problems, but you know how that is.
Hey, Luke, can you send me that picture?
I can indeed.
And don't forget problem set number 1. No one's asked me any questions on it. It's due Monday.
Yeah, that existed.
Have a wonderful day.
Thank you. You too.